discuss about the strain. When an external deforming force is applied on a body, its configuration changes. Now, we will take how much is the change in configuration and relate it to the original configuration. That gives us strain. The strain is defined as the ratio of change in configuration to the original configuration. So we can have strain is the ratio of change in configuration to the original configuration. We have discussed in the stress. We are having tensile stress, compressive stress, volumetric stress, and tangential stress. We will see that in tensile stress there is increase in the length. In compressive stress there is decrease in the length. In hydraulic stress there is change in volume, and in tangential stress there is displacement of upper side of the body, so there is change in length, delta L. And the ratio of the change in configuration to the original configuration yields us the strain. So we have got three types of strain. One is longitudinal strain, that gives us what is the change in length per unit original length. Volumetric strain, that gives us change in volume to the original volume. And shearing strain, that gives us change in length to the original length. Let us take them one by one. So longitudinal strain is change in length, that is delta L to original length by L. So in this case the change in length is delta L and the change in length is delta L. The ratio of that change in length to the original length is the longitudinal strain. Now we will take volumetric strain. When a normal deforming force is applied on a solid, there is change in volume, and that change in volume is equal to delta V, and the original volume is equal to V. So the volumetric strain is change in volume to the original volume, that we can say delta V divided by V. Let us talk of the tangential strain. This tangential strain is also called as shearing strain. And tangential force is applied, so a body is displaced by delta L. So delta L is the change in configuration and L is the original length. So we can say that shearing strain is equal to delta L divided by L. This delta L divided by L can be thought of in this triangle as sine theta. For smaller angle, sine theta is equal to theta. So we can say that the shearing strain is also equal to theta, and that is equal to delta L divided by L. One thing here to see clearly is we may be talking of the longitudinal strain, volumetric strain, and shearing strain, or strain in general. The strain in general is the ratio of the like quantities, that is length and length, volume and volume, length and length. So this strain is unitless as well as dimensionless. Thank you.